this picture, we can analyze from the blue box and me as the object. The blue box is getting pulled with a string, which means that it causes a frictional force to happen between the object and the surface. Since the blue box moves when I pull the string, there is a tension force happening between the blue box and the string. While the normal force goes upwards because it is perpendicular with the surface, and the gravitational force goes downwards towards the Earth because it is pulled towards Earth. Finally, the blue object is accelerated to my direction since I am pulling it to my direction. Here's another example for a free body diagram. We can see that the object here is the cracker. The tension force are on the rope that is holding it up because if the cracker or the rope is being pulled down, the upper rope that is holding the cracker is also getting pulled down. There's also gravitational force on the rope, which is getting pulled towards the Earth. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. This is normally taken as the definition of inertia. There is an external force, which is me moving the object, which is the swing. Because of that, the swing moves and goes out of motion. But if there isn't any action of an external force, the swing will stay and rest. With all of this, we can see that the first Newton law is applied. Newton's second law states that the acceleration of an object is directly related to the net force and inversely related to its mass. Acceleration of an object depends on two things, force and mass. Here, the second Newton's law can be seen as the acceleration of the object, which is the attraction ride, depends on two things, my brother and I's mass, and the force of the setting of the ride that is currently being set on. Newton's third law states that for every action of force in nature, there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B also exerts an equal force on object A. Notice that the forces are exerted on both of the objects. In this picture, there is two forces that can be seen that contributes to Newton's third law, which are action and reaction forces. The rope acts as a transfer to these forces, as the action of Nina and I's pulling of the rope causes the reaction of force in the other team's rope where they feel to be pulled. In this act of tug and war, it can form two actions and reaction. Firstly, for the action is our fingers pressing to the rope, and the reaction to that is the rope pressing to our fingers. Secondly, is our feet pressing to the ground, and the reaction to that is the ground pressing up to our feet. Kinetic energy is the energy of mass in motion. The kinetic energy of an object is the energy it has because of its motion. This picture shows kinetic energy as it shows my body when it is in motion. The kinetic energy is developed from my feet and legs when it starts to move, and it will convert that energy to heat. Potential energy is energy that is stored or conserved in an object or substance. This stored energy is based on the position, arrangement, or state of the object or substance. In this act of going down a slide, a potential energy, kinetic energy, and the law of conservation of mechanical energy could all be seen. Being on top of the slide means that there are still potential energy being stored, but because I'm not yet in motion, there isn't any kinetic energy, meaning that the initial kinetic energy is zero as the velocity is zero. While on the bottom of the slide, the potential energy is already being converted into kinetic energy, which means that there is no potential energy and the kinetic energy could be seen. Adding the potential and kinetic energy will help to find the mechanical energy, which lastly helps to find the final velocity too, as there is definitely speed when I go down the slide. The law of conservation of energy states that energy can neither be created nor destroyed, only converted from one form of energy to another. The law of conservation of energy can be seen in this picture as the act of the person behind my brother and I's car hitting us causes their car's energy to move to our cars. Their car will be slowed down while the energy that transfers to our car will cause our car to move forward. No energy will be lost during this transfer. There's also a sound energy being transferred from the impact of the two cars hitting each other. From kinetic, which is two cars in motion, it will let out a sound. After analyzing the activities before, we can finally answer the focus question and the big question. For the answer to focus question is that humans can analyze transformation based on physics concepts and law, as it helps analyzing and create a structure to follow, such as the formulas and steps. Without us realizing, there are so many physics concepts to be applied in our daily life activities. For the answer to big question is that physics can be found in our daily life, which means that a visionary leader needs to adapt with that world. It also helps with the fact it makes a visionary leader more aware of what's happening with their surroundings. Thank you for watching. I hope this video can help to increase your knowledge regarding the physics topic.